Welcome to video 2 where we'll go over 733 and 734. So from now on in this course, we're going to use continuous functions. So we're going to graph lines, we're going to do exponential, we're going to do quadratic. We won't do step functions unless we indicate otherwise. A third option for investing money is a money market account, which offers 8% annual interest compounded quarterly, which is 4 times per year. This means that the 8% would be divided into 4 parts over the year, and the bank would pay 2% every 3 months. So model this for every 3 months for a $1,000 investment with an equation, and then let y represent the money in the account after x quarters. So as an equation, your original amount is still $1,000, but your multiplier is 1.02, because since you're doing it every quarter, every 3 months, you have to take your 8%, divide by 4, because there's 4 quarters. So that's where the 2% would come from, to x. So then now, every time we plug in an x, it's for 3 months, not for a whole year. And so what that would look like is at 3 months, you would have 1,020, 6 months, 1,040 and some change, 1,061 and some change, and then at 12 months, you'd have $1,082.43. So like, what you can do there is it's going to compound more quickly because you're doing it 4 times a year instead of 1. So it says use the model to predict what would happen in 4 years. So 4 years is 16 quarters. So that's the trick for you, is you have to remember, since it's compounded quarterly, you want to know how many quarters it is. So you would plug it into your calculator. Again, you would have 1,000, and then in parentheses, you have your multiplier. Since it's quarterly, you take the 8%, divide by 4, so that's why it's 1.02. And then we want 4 years, so that's 16 quarters. And so it would be $1,372.79. So if you look to compare what we had before, we had 1,320 on a simple interest. We had 1,360 on a compound interest annually, and then now we're at 1,372 because we are compounding it quarterly. So the more frequent you compound it, the higher it's going to go. And then one more, if you invest $1,000 in the credit union in problem 730, how much would you have in 20 years? If you wanted to earn the same amount of money with bonds of simple interest, what interest would you have to earn? Show how you know. So first, for 20 years, this is back to the original, look, I did it again, the original problem. 1,000 was your original number, 1.08 compounded annually. So that's why we use the 1.08. And then it was for 20 years. Type that in your calculator, you get $4,660.96. If you're going to try to do it, or if you wanted to figure out what kind of percent rate that would have to give you in a simple interest, look how you would plug that into the formula. I equals PRT. I is the interest. And so on this, remember how you put 1,000 in to begin with? That means that's not counting towards the interest. That was your principal. So your interest is $3,660.96. Equals, your principal was 1,000. It's asking for the rate, and the time would be 20 years. So you would take 1,000 times 20 and get 20,000. Then you'll take this and divide by 20,000, so 3,660 divide by 20,000, you get 0.18305. So to make it a percent, it would be an 18% interest rate that you would have to get on your simple interest investment to be able to replace what you did with the compound interest at 8%. So that's why, like, financially, if you are looking to invest, compound interest is the best way to go. If you're looking at a debt and you're going to owe someone money, it is so much better to get a simple interest loan than it is a compound interest loan, because then you're having to pay interest on your interest, and that is not good. And that's a whole other thing that we could be talking about. But compound interest, good when it's investment for you, bad when it's a debt. Have a great day.